So here we have g of x, which is defined by this, the absolute value of x minus x. Remember, we solved this one's graph, which was like this. Again, we compute for some values. F of 0 is 0, and g of 0 is minus 2. And for 1, we solve that f of 1 is 1, and g of 1 is minus 1, right? We put x equals to 1 and get minus 1. So what do? We shift the graph of this function, f, 2 units downward to get the graph of g, right? Because when we put 0, we get minus 2 instead of 0, okay? So instead of 0, here, instead of 0, we'll get minus 2, okay? Instead of 1, we'll get minus 1. So each value will be there, 2 units downward, okay? That's why we shift it downward 2 units and get the graph of g of x. What about this? So I just write these ones to see later after sketching the graph of the given function. So we know again 1 over x, right? So to obtain the graph of g of x, first we need to see this one's graph, find this one's graph. So it's clear that it's obtained by multiplying this function, right? So 2 over x is obtained by multiplying this function by 2. So we need to stretch the graph of f, right, to find this one. So on the graph, it looks like there is no change, but actually we stretched this one's graph, okay? Now to obtain g, we need to compute this. So what do? Here we have minus 2. We need to shift this one's graph 2 units downward as we did there, okay? We had minus 2 and we shifted downward 2 units. So here again we have minus 2. We need to shift it downward, okay, 2 units. So let's look at the values now. So f of 1 is 1, right, here, and g of 1 should be 0. Here we look at that. It's 0. We shifted. That's why it's 0 now. So f of 2 is 1 over 2, and f of g of 2 is minus 1, as in here. Okay, there f of 2 was positive, right? For 2 it was positive, 1 over 2. Now it's negative, it's minus 1, because we needed to shift it 2 units downwards. Okay. What about this? Again, we have we know sinus x, the graph of sinus x. So first we need to find this one's graph. So here we have 3. It means you need to compress the graph of the function that you know better, which is sinus x. So we have this graph, okay? We compress the graph of sinus x horizontally, okay, by a factor of 3, because here we have 3. So we get this, okay? There it was, so for pi over 2, we had sinus pi over 3, we had this, which is square root of, this is not important, but let's look at there. So now for pi over 3, we have this, right? Sinus pi now, okay? So what's sinus pi? It's 0, okay? So it will be 0 in here, okay? So what about pi over 3? I'm sorry. For pi over 3, when we put x equals to pi over 3, we get sinus pi, which is 0. So here we have 0. Okay. So before we had, for pi over 3, we had this value. Now we have 0. Okay. So we compress the graph of the function sinus. Now what do? We want to find this one's graph, right? Sorry, g was defined by that for sinus 3x. Now what do? We need to multiply each value of sinus 3x by 4. It means we need to stretch the graph now vertically, right? Each value will be 4 times of the one of the earlier one. Okay, so we need to stretch the graph vertically by a factor of 4. Now we have, before we had this for sinus 3x, now we have this graph. Okay, so remark that we have 4 now and minus 4. There we had 1 and minus 1. What about this? We have ln of x plus 3. We know ln of x, remember this graph. Now what do? We know this one's domain should be this. Why? Because we know the logarithmic function is defined on positive real numbers. So x plus 3 should be greater than 0. It means x can take values from this interval, from minus 3 to the infinity. So, and also remark that this g of minus 2, when we put x equals to minus 2, we get ln of 1, which is 0. Okay, now the function that we will find the graph, it should be 0 on this point, minus 2. Okay, so here we have x plus 3, right? Inside of the function we have plus 3. So it means we need to shift this one's graph, right, to the left 3 units to find the given function g. So to the left, we shifted this one, right? We had before here 1, now 0, minus 1, minus 2, 3 units. Okay, so on this point, minus 2, the function g gets 0, okay, as we did there, as we computed here. So we have this graph as the graph of g. So what about these ones? Here we have ln of x squared. Remember, ln x was defined, the graph of ln of x was this, okay? Now we have x squared inside of the function. So for negative values of x, it is again defined, right? So for the negative values, we have this, the symmetric, it's symmetric to the y-axis, okay? And what about this one? So this one was ln of x, right? Only this one, the right one. So what's the absolute value of ln of x? So again, here we have already the positive values. Now for the negative values, we need to take its symmetry to the according to the x-axis, right? So we have this. Now we will sketch the graph of this function f. So it's defined piecewise, right? So from the values which are negative, it's defined by minus x. So for the values here, the negative values, we have this line, y equals to minus x. So we knew that before, right? We have this, okay? But it is not defined on 0 because we don't have equality here. So we put this. the empty dot, okay, here. So what about this interval? From 0 to 3, it's defined by this, 2 minus x. So we just first compute the ending points. Okay, we put x equals to 0 and get here 2, right? When we put x equals to 0, we get 2. So we have this point now. What about 3? When we put x equals to 3, we get minus 1. So as it's a line, it's enough to find 2 points, only 2 points on it. So we have this line, okay? How do we know these points? So when it gets 0, you can find it like this, right? So when x equals to 2, it gets 0. So this one is 2. Now, otherwise mean that if x is not in this interval, neither in this interval, nor in here, okay, then it's square root of 2. So it's defined on these intervals, right? On this interval from minus infinity to 3, it's defined. So otherwise mean that from 3, it's not included in the interval because we have already here the equality. So from 3 to the infinity, it's defined by square root of 2. So we get here this constant function. Again, here we have the empty dots because we don't have equality here. Okay. So before finishing this class, you need to know some identities because we will use them to compute the derivatives, also limits. So you should know them. Okay. I'll just explain these ones. Okay, half angle identity. So you should know already these 4 ones. Okay, sum and difference formulas. They are called sum and difference formula. Sorry. So how do you find this cosinus 2 alpha? So you know already cosinus alpha plus beta, right? By this formula. So here we have cosinus alpha plus alpha. So it can be written in this form by this formula, okay? So we get cosinus squared minus sinus squared, okay? Or again, you can write this, that was enough, but again, we can write this one as in this form because you know cosinus squared plus sinus squared equals to 1. So to find cosinus squared, we can write it here. So cosine squared is 1 minus sine squared. So we get this, okay? We had before sine squared. So it's 1 minus 2 sine squared. And also you can write instead of sine squared, this one, again from this identity. So you have this. Therefore, cosinus 2 alpha is equal to this one, okay, this one, which is equal to this, okay, and also equal to that, okay. You should know this identity, this last one, okay. And for sinus, so we know sinus 2 alpha is equal to this one, okay, by again this formula. Sinus alpha plus beta is equal to that. So you just put, instead of beta, again, you put alpha. Okay, so you get sinus 2 alpha equals to sinus alpha cosine alpha plus sinus alpha cosine alpha. So you get 2 sinus alpha cosine alpha. Okay, therefore you get sinus 2 alpha. Okay, again, you should know this identity too. So this one was kind of recall, okay? But we will use all of them. So you need to memorize them, okay?